All right, so these are some results if you take x plus 1 to a certain power. And it's extremely time consuming to get this by hand because, for example, this means you have to multiply x plus 1 times x plus 1 times x plus 1. You have to write this 5 times, and then you should FOIL this out. Right? X times x gives you x squared, x times 1 gives you x plus x, and then 1. So this much gives you x squared plus 2x plus 1. And then you have to FOIL this one out, and then you start foiling and foiling. It takes a long time to get this. Now, however, a mathematician named Pascal realized that you can get these coefficients much easily. And the way you do it is by first thinking of a different way to multiply things. So for example, if you want to multiply x plus 1, you can multiply not just horizontally but also vertically, so that 1 times x plus 1 is x plus 1, x times x is x squared, x times 1 is x. And you add them up, you get x squared plus 2x plus 1. And then if you want x plus 1 cubed, you can do x squared plus 2x plus 1 times x plus 1. And 1 times anything is itself, so that doesn't change. But x times x squared gives you x cubed, x times 2x, 2x squared, x times 1 is just x. Then if you add these, you get x cubed plus 3x squared plus 3x plus 1, just like this result that we have. Okay? And you just keep multiplying x plus 1. But at some point, you see that you can save a lot more time by not writing pluses, because it's obvious that it should be pluses, not writing x's, because you know that this column should be x, this should be x squared, and this should be x cubed. And then you can do the same calculation this way, 1, 2, 1, 1, 1 times, and it gives you 1, 2, 1, 1, 2, 1, 1, 3, 3, 1. Simple, right? Yeah. And then what about the next one? It's 1, 3, 3, 1, 1, 1, so you get 1, 3, 3, 1, 1, 3, 3, 1. You add them, you get 1, 4, 6, 4, 1. Okay? And then let's just do one more, because some people are confused by what I'm doing. I'm not just doing multiplication of two numbers that's like this, because it's 1, 4, 6, 4, 1 and 1, 4, 6, 4, 1. If this was a regular addition, I would be writing 1, 5, and then there should be a carryover, but there aren't. This is really what? This is 1x and x squared. This is really 6x squared plus 4x squared. So if you add them, you get 10x squared. You see what I'm saying? Okay. So this should really be 10. And then this should also becomes 10, that becomes 5, and that's one. Okay. And then further investigating, you can see that you can reduce this further. There's so much redundancy here. You always write the same thing over here, and then you shift over and write it again. So in essence, what's happening is like you're adding neighboring digits, okay? So Pascal realized, well, don't do it that way. You can do it even simpler. Just put 1, 1. That means x plus 1, right? And then 1 goes here, 1 goes there. Then the sum of these two adds up to get 2. Okay? Then 1 comes down here. 1 plus 2 gives you 3. 2 plus 1 gives you 3. 1 goes from here. What's the next one? You put 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. Okay. 1, and then you have 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 5, 1. Okay? Just keep going. Okay. Now, what do those coefficients mean? Well, this means this. X plus 1 to the 5th power is exactly this. 1, 5, 10, 10, 5, 1. That's what it means. Okay. All right. So that's what Pascal's triangle is, and it was made by a very smart individual, Blaise Pascal. He lived in the 17th century. But there's a whole different aspect to this. So here's like a totally different way of understanding this formula. Okay, let's try to be lazy and let's try to, well, let me pose this as a question. Example one. What is the coefficient of x cubed if x plus 1 to the fifth is expanded? Let's try to answer this question. And of course, I can take time to expand this out, or you can use the Pascal's triangles. We already know the answer is 10, right? But let's say these numbers were much bigger. Let's say this was x plus 1 to the 12th power, and this was something like x to the 5th power. If you had questions with higher numbers, it still is time consuming to like build this until the 12th level. That's like a lot of work, right? So I want to be even more lazy and try to figure out how to figure this out without having to go through Pascal's triangle. After all, what is math? Math is really a bunch of shortcuts that you begin finding, right? And the more shortcuts you know, sometimes there are some cases in life that you end up using them for your benefit, especially if you're writing a bunch of computer codes. Sometimes you find these weird patterns and you think like, why does this happen? And there's some mathematical reasoning behind it, okay? Right, but coming back to this question, let's try to find a pattern here. So solution is, write this out. Oh, 1, 2, 3, 4, 5. Okay, so I wrote this 5 times. And think about how you can get an x cubed. So you could get an x cubed if you multiplied x, but then 1 and 1. Okay? If you expand out, at some point, this x is going to get multiplied to this x, and then this 1 and this 1. That's going to create x cubed. Right? Do you agree? But there are other ways to make an x cubed, right? So you could also have x times 1 times x. That's still another way to get x cubed. Is that right? Okay. So after investigating this further, you realize, well, this is just like saying out of 5 bags, each bag has 1 x and 1 1. Okay? There's 2 cards, there's an x, there's a 1. Okay? And you're trying to figure out how many ways you can choose 3 x's and 2 1's. If your 5 bags each has 1 and x. Well, you get what I'm saying? Yeah, your 5 bags, every bag has 1 and an x. 2 cards, 1 and an x, and then you're trying to choose from 3 of them, choose x, from 2 of them, choose 1. But that's equivalent to saying that I have 5 bags, I need to choose 3 bags out of the 5. How do you write that? I need to choose 3 bags to draw out x, right? And that's the same thing as saying you have 5, choose 3. Okay, let's see what 5 choose 3 does. 5 choose 3 means, according to the formula that we learned last time, it's 5 factorial over 3 factorial. And then 5 minus 3 is 2, so you put 2 factorial. And that's the formula for n choose. So also written like this, 5 choose 3. 5 choose 3 is put 5 and 3, but then you have to subtract the two numbers and put another factorial there. And then you keep multiplying out the factorial 5 times 4 times 3 times 2 times 1, 3 times 2 times 1, times 2 times 1. And you see that 3 2 1s cancel. This is 20. 20 divided by 2 is indeed 10. So it worked. We did get this 10, which was the coefficient of x cubed, right? Yeah. Pretty amazing, right? Okay. Now, that tells us something. That tells us that what we know as the Pascal's triangle is nothing but 1C0, 1C1, 2C0, 2C1, 2C2. Okay. Now, you have to remember the convention that we have 0 factorial equals to 1, okay? So, the way I'm thinking of this is like, in this case, I have 2 bags, right? 2 bags. It doesn't matter which one you try. Let's leave it like this. You have 2 bags, and if you choose no bags for ones, so that both of them are x's, that's going to give you x squared, right? So the number of ways you can get x squared would be 2 choose 0. Okay. Now choose 1 means you choose one bag to draw out the 1. The other one we are going to take x. Okay. In that case, that's going to be x. This will be the coefficient of x. What is 2 choose 1? 2 choose 1 is 2 factorial over 1 factorial. And then 2 minus 1 is 1. That's just 2. So it's exactly this number here. Okay. What's 2 choose 2? 2 choose 2 is 2 factorial over 2 factorial. 2 minus 2 is 0. As I said, 0 factorial is 1. Anything divided by itself is 1. So that number corresponds to this. Okay, so if we just use what we just figured out, if we take this observation and reinterpret all the numbers in the Pascal's triangle, these are nothing else than a bunch of numbers that you get when you do something choose something. So you get 3 choose 0, this will be 3 choose 1, and this will be 3 choose 2, 3 choose 3, and let's just write one more. So you have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. And in fact, if you wanted to know 4 choose 2, you can just go to Pascal's triangle and say, hey, it should be 6. Now there's another observation that you gain by comparing the two. See, remember how we got this number? We got it by adding these two, right? How did we get this number? We got it by adding these two. So it looks like 4 choose 1, for example, is the sum of these two. We get 3C0 plus 3C1 equals to 4 choose 1. Now, it would be hard to think of this identity without having the Pascal's triangle as your example, but it ends up being this. And it looks like what's happening is that this number will always be the next level, and you get two neighboring things. So I think the formula here is, if you want NCM, this should be n minus 1 C m minus 1 plus n minus 1 C m. So you have this as an additional identity between the combinations that you can actually take this and prove it, but you get it from here. Okay? So let's try out this question. Find the coefficient of x when this thing is expanded. Okay, so what does that really mean? Well, if you expand this, everything will be some coefficient, unknown, times 2x squared to some power, and 1 over x to some power, another power. Do you agree? Now, the sum of p plus q should equal to 5, right? Should be 5. Because this is fifth power, this should be 5. Now, if you didn't get it, you can also think of it this way. What does that mean, expanding this? What does that mean? That means you're writing this 5 times. And when this gets expanded, you're really making a choice. So maybe from this bag, you chose 1 over x. From this bag, you chose 2x squared. Maybe 2x squared again, and maybe 2x squared again, and then you chose 1 over x. Okay. If you multiply them, how many times did you multiply 2x squared? 3 times. How many times did you multiply 1 over x? 2 times. So 2 plus 3 should be giving you 5, right? So that this p plus q must be 5. That's the thing that you have to figure out, okay? However, we want at the same, I shouldn't have erased this part, okay. At the same time, we should also have the coefficient of x. So I want this to be something times x, where this is a number. This is what we want. But this should be x to the first power. In other words, 2p minus q, because this, see, x squared to the pth power is x to the 2p, and 1 over x to the qth power is same as x. 1 over x is x to the negative 1 power. So if you take the qth power, that's x to the negative q. So if you multiply these two, you end up saying that this is equal to x to the 2p minus q, with something in front. It's 2 to the p and then something. Is that okay? And because these two need to be equal, 2p minus q should equal to what? Okay, let's just call this unknown coefficient something like a. Say a. I need to find out what that is. But then this will be a to the 2 to the p power x to the 2p power times 1 over x is x to the negative 1 power, and negative 1 to the q power, that's negative q. Okay? Therefore, a times 2 to the p times exponents add up, right? So you have 2p minus q. And because I need the coefficient of x, x by itself is x to the first power, right? So that means I need 2p minus q to be what? Huh? No. What do I need 2p minus q to be? 1. 1. I need this to be 1 so that I know exactly what's the coefficient of x, so first power. That's what the question is asking for, right? So I need this to be 1. And if you add them, you get 3p equals to 6, p is 2, and q must be 3. Okay? So what does that mean? That means if I expand 2x squared plus 1 over x, if I write this 5 times, 1, 2, 3, 4, 5. then from 3 of the bags, I need to choose 1 over x. From 2 of the bags, I need to choose 2x squared. Okay? So one possible way would be take this, and then take these. That's going to create what? That's going to give me 2x squared, 1 over x, 1 over x, 1 over x. X squared times x squared is x to the 4th. Right? 2 times 2 is 4. X is x cubed. But then x to the 4th divided by x cubed, that just gives you x. Okay. So it does create something times x. But that's not the only x term that this is going to produce if you FOILed everything, right? If you took like 2 blank letter-sized pages and you did the FOILing out really carefully, right? And after 2 pages of calculation, you're going to get a bunch of these things coming up, right? But we need to count how many of those we get. Right? So how can we figure out how many we get? How many of the 4x's should we get? And hint is use combinations. If nobody can answer, I'll give you a homework, which is to actually expand that out, the entire thing. It's going to get 2 pages.
Is it 5 choose 2?
Yeah, it's 5 choose 2, right? You're choosing 2 bags to choose the 2x squared from, right? And the same thing as 5 choose 3. Because another way to say it, you're choosing 3 bags to take extract 1 over x from there. Okay? Yeah. So either 5 choose 3 or 5 choose 2, they're the same. So I spoke about this last time. NCR is the same thing as NC n minus R. So that's true. And that one is something that we just did earlier. This came out to be 10, right? So the answer to this question is it's 10 of the 4x's, so you get 40x. Okay, try this out. I'll give you some time to think about this. Same thing. So from here, there are certain cases where you get x to the 4th. So the beauty is about trying to do something, but without doing it, just imagine that you're doing it. Okay? So imagine that you're expanding this out. You do this times this times. So if you expand, how do things expand? Something in here gets multiplied to something in here, right? These two don't get multiplied because they're in the same bag. It's either this with this, or this with that, this with this, or this with that, right? So that's like when this is expanded out, but then this time this is going to get multiplied to this one, or this time this could be multiplied to that one. Yeah. But never 2 things in the same bag. It's always 1 thing from each bag multiplied together. And what you're doing is you're expanding out every possible cases, and you're collecting the like terms. That's what's happening, right? So what you should do is like, when would something of the sort x to the 4th will appear? That's the question. And x to the 4th is going to appear, well, there's not much you can think of it. It's either 2x squared to the 5th power times 1 over x to the 0th power, because I know that this should be adding up to 5, right? Yeah. or it could be 2x to the squared to the fourth power times 1 over x to the first power. This will be like, in 4 of the cases you've chosen 2x squared, and in just 1 of the cases you chose 1 over x, right? Okay. But this is definitely bigger than that. 2 times 5 is 10, so it's out of the question. This is what? 2 times 4 is 8, and then you divide 1 out, so it's the 7th power. So that's going to give you something times x to the 7th. Look how lazy I am. I'm not even bothering to write what this is, okay? I don't care what 2 to the 4 is. I just need to know when I get x to the 4th. So just don't bother this. I just figured out, so that's nothing. So what's the next one you can try? You can try third power, and this one will be what power?
2.
2, right? But then what's that? That's x to the 6th power divided by x squared. What's that? That's x to the 4th power, isn't that right? Okay, so now you see that, oh, the way you get x to the 4th is when one of these 2x to the 2x to the squared gets powered by 3, and 1 over x gets powered by 2. And if you simplify this, 2 to the 3rd power is 2 times 2 times 2, which is 8. So you must be getting 8x to the 4th. That's what you're going to get. Each of these choices of 3 of 2x's and 2 of 1 over x's will give you 8x to the 4th. Now the question is, how many of these do you end up producing if you expanded this? The answer is, you have 5 bags, and you're choosing 3 bags, out of which the 2x squared will come out. And that is the same thing that as before, it's 10. So you get 10 of these. If you collect them, what do you get as the final result? 10 times 8x to the 4th, which is 80x to the 4th. Done.
Yeah.
Did that make sense?
That makes sense. Yeah.
Okay, good.
Thank you.
All right. The binomial theorem, and it goes like this. X plus y to the 5th power, according to what we just figured out, it's 5 choose 0. Let me use this other notation. 5 choose 0, x to the 5th power. Let me use 5. 5 choose 0 is the same as 5 choose 5, okay? X to the 5th, y to the 0th power, plus 5 choose 4, x to the 4th power, y to the 1st power, plus 5 choose 3, x to the 3rd power, y squared, plus 5 choose 2, x to the 2nd power, y to the 3rd power, plus 5 choose 1, x to the 1st power, y to the 4th power, plus 5 choose 0, x to the 0th power, y to the 5th power, okay? And if you actually calculate out the numbers, these are something that you already know. This is 1, 5, and then 10, 10, 5, 1. The number that you get from the Pascal's triangle. Okay? 1, 5, 10, 10, 5, 1. And since this follows a pattern, this is a perfect example for us to use the sigma notation. Okay? So let's use k from 0 to n. And instead of writing this way, let's start with this one, this one, this one, this one. So 0 through 5, right? So the top one's always 5, but k goes from 0, 1, 2, 3, 4, 5. So if I put k here, that's what you get, right? Okay, now you have to figure out what to write here. X to what power? And y to what power? Can you figure out what goes here and there?
X is to k,
Mm-hmm. And
and y is 5 minus k.
5 minus k. All right, so that's known as the binomial theorem in general. If you have x plus y to the nth power, that's going to be summation of k equals 0 through n. N choose k, x to the k, y to the n minus k. That's the binomial theorem. Now, we need this for statistics. So one of the things that you use this for statistics is, well, if, so let's talk about binomial distribution. Let's say you have some spinner, okay, with yes and no having different proportions. So if probability of getting a yes is probably be P, then the probability of getting a no would be 1 minus P. Are you okay? Yeah, so they should add up to 1. So yes would have probability P, and no would have probability 1 minus P. Now, question is, if I spin this 5 times, what is the probability of getting exactly 3 yes and 2 no's? Okay. Well, the next topic is probability. So this, it's okay if you don't fully understand this, but there are many ways that you can get 3 P's and 3 no's, 3 yeses and 3 no's, and it could be yes, 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 no, no. It could be yes, no, yes, no, 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 yes. And you have a bunch of different ways to do it, right? Now, how many different ways can you count? You have 5 spots, right? And what are you doing? You're choosing 3 spots to get the y in, right? The remaining 2 spots will be filled by n. So the total number of possible lists that you can write this, we can permute this, would be 5, choose 3. Or another way to say it is like, it's a permutation with repetitions, right? So you're permuting 5 objects, but there are 3 yeses and 2 no's. There, you see 1, 2, 3 of the same thing, 2 of the same thing. So that's the number of ways that this could be permuted. Okay, that's exactly the same as this, right? Okay, so that's going to be 10. But then, what's the probability of each one of these happening? What's the probability that you get y, 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 and n for this spinner? Well, that's like probability of getting a y is p, and probability of getting a no is 1 minus p. And we're going to learn this later, but when you have multiple things happening at the same time, that's simply multiplication. So you end up with p to the third 1 minus p squared. And therefore, the answer for this question is 5, choose 3, p to the third power, and 1 minus p to the second power. Okay? So that's called binomial distribution. And one of the things that you keep saying is, in general, probability of x, let x be the number of yeses. Okay, so x being k is equal to 5, choose k, p to the kth power, and 1 minus p. This is also known as q, okay? 1 minus p, 5 minus k. And this is just a special case when k is 3. And that's since k could be anywhere between 0 through 5, the maximum yeses you can get is 5. The minimum yeses you can get is 0. You can get all no's. There still is a probability. So k ranges from 0 through 5. And now the question is, next question is, if I say question 2, what is the sum of all the probabilities from k equals to 0 through 5? And the answer to this is you get k equals to 0 through 5. 5 choose k, p to the k, 1 minus p to the k, 5 minus k. And then you compare this with this rule that we just proved, binomial theorem, right? And that's exactly this with n equals to 5, x equals to p, and y equals to 1 minus p. So what's that? That's going to be p plus 1 minus p to the 5th power, which is 1 to the 5th power, which is 1. Okay? And that's needed when you try to show that this is a probability distribution. Okay? Probability distribution has to have a property that if you add everything, you should get 1. So that's needed. And then there are further calculations like in your statistics course, you probably have saw that in a binomial distribution with n trials and p as the probability for success, this is going to have np as the average value, and actually average will be np, and standard deviation should be square root of npq. So you probably have seen this somewhere in your statistics class. And both of these can be shown by making use of this binomial theorem. Okay?